Hello, and welcome to I Got an Idea. I'm showing you Schrödinger's numbers. Now, what is a Schrödinger number? A Schrödinger number can be symbolized by this or this. This is for swap. Split. What's the difference? Swap means it swaps between the numbers, so for this example 4, add 0 every other line. So 4, 12, 18, this would go down, but during this, so this becomes 16, and it swaps to 0. Then it swaps again, and it becomes, this 0 becomes 18. Then it swaps again to this 16. This, and since there's no more go, it becomes 16 to the power of 2. Which, in this case, I believe would be about like 36. So that's the swap aspect. It constantly switches, which cancels out certain ones. Split, on the other hand, is different. This one is not designed to give students an aneurysm, but actually might have a use outside of giving students an aneurysm. It splits into 2. One where the 4 equals 0, and one where the 4 equals 4. So, in this case, it becomes, this is 36, and this becomes 4 times. And this becomes 4. Then you compare. This is your answer. Meanwhile, this one, this is your answer. It's pretty interesting. Now, what uses do we have for this? This, I believe, would only be useful for giving students an aneurysm, that's it. I don't really think there's any use. This, on the other hand, could be used for something. What is that something? I don't know, I'm not a mathematician. That's all. Hope you enjoy the numbers. Bye. Just kidding, it's not over. Yay! So, let me clean this up more so you guys. So, another rule. The main number can be anything at the start. It could be a 7, it could be a 12, a pi. Any number can be main. But the secondary number it swaps to every other time, that's always 0. It will always be 0, and then changes over the equation. This means that it can't go from 6 to 8 without something happening in between that changes the 0 into an 8. So, let's do this for example, a longer one. First, we have 7 divided by 9. So 7 divided by 9. That is, we're going to round it to, we'll save that for later. This is now all, I don't know why I did that. This is all now 0 squared times 12 divided by 2. So, now we got this. So now it's 0. Well, that's still 0 times 12. So, now that's it. So, 0.7 0.7 x12. 8.4. So now it's 8.4. Divided by 2, except, nope, it's actually 0 divided by 2. Or 0 over 2, or 0. So that means the final result is 0. Which, another thing, this, it can involve an entire equation inside of it. It just has to have a number inside. A symbol that means a number, just as long as it's a number. So this, and also, in doing so, it does anything inside of it, any equation you do there? Nope, doesn't change it. It has to involve something outside. So this is the square root of 7. So the square... So if we were to do... the square root of... I'll say, let me try. There it is. The square root of 7. 2.6, we're rounding it to that. That's the answer. But the instant we have 1 plus that, that's when it swaps to 0. This one, and boom, now the answer is 1. See how that works? Now time for the final one. So first we have this, which is square root of 12. This can be done before. So that means now it is. Now we're going to round this to the nearest 10th, or well, 100th, I think, because it's an irrational one, and I don't want to deal with the irrational. But here's something you should know. Guess what? This is outside of this one, meaning this one swaps. Remember, it only applies to that one. So, now what is 3.46 times that? That is 31.14. So now, 31.14, and this swaps again. Same for this. So it's 0. Well, this becomes pi. Afterwards, it is 0 over pi, or 0. That's the answer again. So, that's kind of how it works. Yes, this is designed intentionally to be challenging, but it's interesting, it's fun. It's fun to do. It's fun to give your students a little. So, yeah. I don't know what this would be used for, but it is something new. And it's something. And I'm like, do with it what you must. Just, yeah. Do with it what you must. Bye.